All right, mathletes, talk about multiplying matrices today. This is our last lesson in chapter 3. So let's talk about matrix addition and subtraction. So we know that with addition and subtraction, the dimensions have to be the same, right? So in order to add and subtract, we have the same dimensions, right? And remember, dimensions are the row and the column, right? So row by column, so 3 by 2, 4 by 1, etc., right? And if they're not the same dimensions, so you can only do it when you have the same dimensions. If they're not the same dimensions, then remember we wrote impossible, right? Okay. So with scalar multiplication, basically all we did is distribute, right? We just distributed a constant to each element in the matrix, right? And so we just multiplied a constant times the entire matrix, and once again we just multiplied that constant by each element in the matrix. Okay. So we're going to talk about matrix multiplication today, which is a little bit different. So for one, with matrix multiplication, the dimensions don't have to necessarily be the same, but what does have to be the same is the number of columns in the first matrix and the number of rows in the second matrix. Okay, so when we multiply, if you have matrix A times matrix B, and let's say A is a 3 by 2, and let's say B is a 2 by 4. So that can work because this matches up with this. Okay, so those have to match up. The columns of the first matrix have to match up with the rows of the second. And after you multiply, what you're going to end up with is the number of rows of the first and the number of columns of the second. Okay, so if I multiply matrix A by matrix B in this situation, I would end up with a 3 by 4 matrix. Okay. All right. Now, if the rows, or excuse me, if the columns of the first don't match up with the rows of the second, then you say undefined. Okay, so that's what we say in this case. So not impossible, but undefined when they don't match up. Okay. All right. So let's take a look at some of these examples. So it says determine whether each matrix product is defined, right? If so, state the dimensions of the product. Okay, so number one, we have a 2 by 5 A. Matrix A is a 2 by 5, and we have B, which is a 5 by 1. So do these middle numbers match up? Yeah, the columns of the first match up with the rows of the second. So it is defined, right? And so now let's list or state the dimensions of the product. So the dimensions of the product would be the rows of the first, columns of the second. So it would end up being a 2 by 1. All right. So if we multiply 2 by 5 by 5 by 1, we end up with a 2 by 1. Okay. And I'll show you how to multiply in a minute, but this is just to get an idea of first of all what we can multiply, right? So number 2, is this defined? Well, the columns of the first match up with the rows of the second, so that works. And our resulting matrix is going to be the rows of the first and the columns of the second, so it'll be a 1 by 2. Okay, so 1 by 3 multiplied by 3 by 2 is going to be a 1 by 2. All right, let's take a look at number 3. So number 3, do the columns of the first match up with the rows of the second? No, they don't. So our answer is going to be undefined. Okay. All right, number 4, columns of the first, rows of the second. Take the outer terms or the outer values, and those become our dimensions, right? Oops, sorry. know why I put 2. So this case, it's a 4 by 1. Sorry about that. So 4 by 1. All right, so then I'll do number 5 and I'll let you do number 6. So number 5, we have a match, and our resulting matrix is going to be a 3 by 4. So try out number 6.